Hi guys, welcome to part 3 of how to build an NFT Marketplace application video series. So this NFT application which you see here will be built using Next.js, Polygon, Hardhat and TailwindCSS. This application allows us to buy, sell and list NFTs currently for sale in its marketplace. It connects to the Polygon network and uses Matic as its currency. And in part 3 of this video, I'll show you how to build the front-end Next.js application for this project. So that's what we'll do here. So first, make sure to get the code skeleton for this tutorial by going to my GitHub repo for this project, which is posted in the video description. Select front-end app to front-end app, and then click on code and then download zip. This will download a zipped folder to your downloads folder. Extract that and import it into your coding workspace to follow along. This will make following along much easier. Alternatively, you can also build on the project from part 2 or 1 of this series if you are following along from the beginning. So that being said, now we can go into the coding workspace. So this is the NFT Marketplace application, the Next.js front end, and then the package.json file inside the front end application. So now we see a list of dependencies, and in order to install these dependencies, we must install them using npm install. So run this command in order to install all of them. I'm not going to because I already have them installed. So once that's done, we can start with coding. So let's build the app.js file first. So this file right here, this is our main app component. It receives two parameters in the form of component and page props. Component is basically the currently active page component, which will be constantly changing when the route to our application changes. Page props is the initial data that will inject into a page when the page is first loaded. This is mainly done by calling get initial props from any component of the app in the application. The coding for the navbar component won't be covered in this tutorial, but you can easily grab its code by visiting my GitHub source code repo. Now we can move on to the index.js file. So over here, we're going to add a basic layout. So let me start off by adding a div here, and we're going to say styles container. So this will apply some CSS styles that we've defined in our styles folder. Notice that unlike traditional web frameworks, we don't specify CSS class names with double quotes or single quotes. We do it by using a dot notation. So this is some of the quirks of Next.js. So let me speed things up here. So this is the head of the application. Then we can add the main. So this is where the main home page of the application will be rendered. And then we can add a footer. So this is the default footer that comes with create Next.js apps. So now, yeah, so this is just a basic layout. The only difference is we've added marketplace, which we will cover in a second. So now we can go to marketplace. So in the pages directory, I've created a subfolder called marketplace, and inside it we have the marketplace.js component file, and then in here we can add some code. So this is going to be our home page. So let me first type out the important code, and I'll then proceed to explain what it does. Selected NFT So remove this semicolon here, and then NFT fonts categories would be right here. So what we're doing here is const NFTs, and set NFTs is basically using the useState React hook. This NFTs variable is used to house all the unsold NFTs that will be obtained by calling the market smart contracts methods. So once we receive all those market items, it'll be contained in this array. Right now it's empty because we haven't called it yet. And then in selected NFT category, these variables are used to provide the filtering functionality shown in part 1 of this video series. So how we can filter from animals, clothes, electronics, music, art, or all. So the default state is going to be all, meaning it'll show all the items regardless of its type. And then NFT categories is basically the category of the NFT. Right now I've whittled it down to just 5, but you can feel free to add more if you want. Next, we'll use a use effect React hook, and we're going to call load NFTs, which is a method that hasn't been defined yet. So it's basically an asynchronous function. And what useEffect does is it basically runs its body, it runs this callback function whenever the first render event occurs. So upon initial page load, it'll run the load NFTs method. So now we can move on to load NFTs. So let me type this out first and I'll explain later. So market address, and if you're wondering where we're getting market address, over here we're importing market, the JSON file, and market address is the address of the configuration file that we created from last video or from part 2. If you're a bit unsure or confused, feel free to look at part 2 where we covered building that configuration file, because it's only when we have the address of the market contract that we can call it, and in order to get it we had to write it to an external file. So here what we're doing is we're instantiating the contract on this map, and we're basically getting the items, all unsold items in the smart contract, or that have been deployed to the smart contract. And once we get those items, we're going to save it in the items array by implementing the following code. So basically, we're going to use Axios to get the token URI. And then we're going to use the ethers library, utils, format, units, I.price to string, and we'll price it in ether. So we're converting the price to a string format. Then we're defining the format of the item. So first it's going to have a price field, and token ID, we're going to convert the token ID to a number. Then we're gonna have the seller. Then we're gonna have the owner. And we're gonna have the image. So the image was stored in IPFS Infura, and we're basically calling meta using that Axios GET request, and we're providing the link to that image. So it's hosted in the Infura server somewhere. We just need to grab that URL so that we can reference it when we display the image in the home page. And then we're getting a bunch of other data too, so the name, the description, and the category. Metadata category. So once we get that, we're going to return the item. Okay, so basically load NFT, hold on, there's a bit more. Items, yeah, so we're going to set the items to set NFTs so that all the NFTs can be loaded. Then we're going to say the loading state is done loading. So once the items are loaded, okay, we're done loading, we can render the necessary layout. So basically this method calls the fetch market items method, and to get a list of all unsold market items. Then we use the map function to encapsulate it in a promise to store all the NFT items in the items array. Finally, we return the items variable, and we're able to render using our render function now. So now we can move on to our next function. And this one is called buy NFT, and basically it buys NFTs as the name would suggest. So I'm going to code this out first and I will explain it shortly. So first we're defining a Web3 modal. So Web3 modal is, if you watch the part 1 demo video, you've noticed that a pop-up window came up whenever I click the create NFT button in that form, and what's causing that pop-up window to show up is this Web3 modal. And so now we're going to define the contract, the ethers contract, NFT market address market ABI and signer. Ethers to string So here's the logic that we use to create the sell transaction. So when we're buying something, we're buying it so that that item has ownership to us, so we have ownership of that item. So in order to make the smart contract reflect that, we need to call create market sale method. Okay. So in the buy NFT method, when the user clicks the buy button under each NFT displayed on the page, it'll call the create market sale method with the NFT's token ID and price in order to complete the sale. And then once that's after the sale is complete, the load NFT method is re-executed in order to update the list of unsold NFTs in the marketplace. So once you complete the purchase, one of the unsold NFTs in that marketplace is currently sold, and it's showing outdated information. That's why we call it load NFTs, to make sure we are showing the right information. And if you're wondering what ABI stands for, so Market ABI, ABI stands for Application Binary Interface, and it's basically the interface between two program modules. So it basically helps us connect from our JSON file, which we see here. You can see we're importing market. So this was compiled by Hardhat, and it produced a JSON file. And using the ABI that was defined in this JSON file, we're able to connect our front-end application to our smart contract. And we also need the NFT market address as well. So next we can go on to the render method. So this one I'm just going to paste on here for the interest of time, because it's quite long. But this is basically what it looks like. So first we check the loading state. Is it done? And do the NFT state variable have a length that is not 0, greater than 0? If, or no items. Does NFT have a length that is 0? Then we return no items in marketplace. Else, then we go to our return statement, and so now the NFTs are loaded, and we're returning this layout here. And the important section is right here, where we see NFTs.map. So we're mapping over the NFTs array, and now we're deciding if there's a category for this NFT. We're going to basically render it according to the category. So we're going to say category.nft category, but if it has no category, then we'll just say no category, because not all NFTs have categories. It could be undefined, so in that case we'll render no NFTs. And then we have the else condition in this ternary operator right here. So if NFT category is all, then we render all of it. But if it's something other than all, meaning the filter function is applied, then what we do is we check the NFT category to the selected NFT category. So let's say this is electronics. If an NFT category has the same value as electronics, then only then would we render the logic. So that's how the filtering functionality is done. This is just a redundant comment we can delete. And basically that's our marketplace application. So now we can go to the create NFT file, where we can define the create item component. So give me a second. Yeah, okay, so first let's define watch loading spinner. So this is basically the loading spinner that shows up when a transaction is taking place. So when we call methods in the smart contract, they could take up to 20, 25, or even 30 seconds. Because it's quite a extensive and complex process. So in order to indicate that to the user, and so that the user doesn't feel like the application froze or something, we implement a loading spinner so that the user is able to infer that, okay, we just have to be patient for a couple of seconds while the application processes our transaction. So that's what we're doing here, and we're using the watch method or object in the React Loader Spinner library. Now we're going to code out some state variables, and we're going to use the useStateReact hook. So file URL is going to house the URL of the image file. So instantly it's going to be uploaded to Infura, IPFS Infura, and then we're going to grab that URL and then assign its value to the file URL variable so that we can render a preview of the uploaded image onto the form itself. So it's helpful in letting the user know that, hey, okay, so this is the image for this NFT that you're about to upload. And then we set form input, so the line above is basically the state variable that's gonna store all the information for the form, so price, name, description, and category, all stored in that one variable. And then we have show loading spinner. So the show loading spinner is used to indicate whether or not to show the loading spinner. And router is used to route the user to the home page once the posting transaction. So when the user creates the NFT and it's been approved and everything is successful, we want the user to be redirected to the home page. And that's why we have defined router. So now we're defining this function called onChange, and onChange is basically a method that is used to render the image for the NFT that is about to be uploaded. So it's nice to have the user show, it's nice to show the user a preview of that image, and what we're doing here is we're referencing the IPFS Infura URL and we're adding the image path so that the user has something to see. And the way we do that is by calling file set URL, and then we catch if an error occurs, saying error uploading file error. And the way we upload the image file to the, or all the data to the, just the image file because it's files, 0. The image file to IPFS Infura is by using client.add file, and then depending on the progress, show a progress indicator. So next, we're going to code the async create market function, and it's basically used to process the form input data that is received from the user submitting the form. So JSON stringify. We're going to grab all the form data and then put it into a variable called data, which will then be stringified, so it will be made a string object, and then we're going to upload that data to IPFS Infura, so await client add data, and then we're going to paste in a URL, and this is the IPFS Infra upload link. Then we're gonna log out the uploading URL. Console log URL. And then now we're going to set the loading spinner. So now that we're uploading to Infura, we can say, okay, show the loading spinner now, because we want the user to know the transaction is taking place, so that they know to be patient and give it a few seconds. Uploading file. Okay, so yeah, so create item, this is the method that extracts form data and validates whether they contain valid information. The data is stored in IPFS Infura. In case you didn't know, so IPFS Infura is a distributed system for storing and accessing files and data. After this, the IPFS link is provided to the create sale method right here in order to proceed with the sale transaction process. And the create sale method is what we'll define right now. So here we can render a Web3 modal instance. In order to create the sale, we're going to have to use MetaMask and confirm that transaction via the MetaMask modal that we saw in part 1. And in order to do that, we have to write the following code. So we're instantiating a Web3 modal, providers, Web3 providers, connection, so ABI code with parse units. We're going to convert the price to ethers, and then we're going to instantiate the contract. So contract NFT market address, market ABI, signer, transaction, contract. So before we start the selling process, before we start the selling process, we have to create a token, and this token is basically going to be a universally unique identifier for this NFT, and it's basically going to be its ID. And as we've defined in our part 2 video, once we call create token here, it's automatically going to call create sale. So let me quickly go over that. So right here we can see create token, and then creates the token, set token URI, and then it creates then it calls create market item immediately within create token, and this method will create the market item. So that's why in create sale we didn't have to call create market item, because create token is doing that job for us. So now after we've created that transaction and it's been successful, now we can redirect the user to the home page via router push. So that's basically what this method does. It instantiates that process, so it makes the modal show up. Once the user clicks confirm, the transaction takes place, and if it succeeds, then we go to the home page. Next, we'll paste in the render logic, and here what we're doing is we're defining a form, sell NFT, and for the input fields, we're calling update form input. So this is a state variable for the useState hook, update form input. And we're using the ellipsis operator to transfer over the old functionality or old data along with a new value for the name when name is updated, a new value for description when description is updated, a new value for category when category is updated, which is a select option field. And then we have input for the file. So this is the image file, and on change we're going to call the on change method, which we've defined here. So it's going to upload the image to IPFS Infura, and then it's going to set file URL here, so that over here we have an image element with a source of file URL, which will display that image. Then we have the create market item on-click listener for this create digital asset button. So once it's clicked, it'll start that process to upload the file and create the market item. Then we have show loading spinner, basically showing the loading spinner if the state is set to true. And that's basically it for create NFT. So this is our basically our posting form where we can add an NFT. So next we'll go to my assets. So in my assets, we'll code out the assets that are under, or we'll display the assets or NFT market items that are under the current user's control or ownership. And to do that, we're gonna use code that is very similar to create or Marketplace.js that we've recently defined. So let me speed things up a bit. So we have NFTs and loading state, and then we're going to call load NFTs. Load NFTs. And let me speed things up here. So yeah, so NFTs is going to hold the market items, but there's a key difference here. So NFTs here, it's going to hold the sold market items. It's not going to hold the unsold market items, because this is my assets. So anything that is under the user's current ownership will only be displayed. Then we have a loading state, which I don't think it's used, but it's there anyways. Then we have load NFT. So basically we're rendering a modal, Web3 modal, and then the key difference. So this is very similar to Marketplace's load NFTs. Load NFTs here, because we're using the same logic, with a key exception of market contract fetch my NFTs. So fetch my NFTs fetches, so let's see, it fetches the unsold NFTs. Fetch my items returns only items that a user has purchased. So that's the key difference here. And then all the items that the user has purchased are stored in items and then set to items, and then the loading state is true. It could be that the user has no items under their ownership. In that case, items contains a zero length array, and it'll be handled accordingly, meaning it'll show the following message. So if loading state and NFT's length is 0, then we'll say no assets are owned. Else, meaning the length is not 0, then the assets will be mapped using the map function. We'll iterate through, and then we'll create that layout, which you saw in the demo video part 1 of this series. So that's basically it for my assets. Pretty straightforward application. Again, so I'm not covering all the functionalities such as navbar right here. So if you want to grab the navbar code, just visit my source code repo. I'll link it in the description. So anything you need, just grab it from my folder, and you can merge this functionality to an existing app you have if you want. And then finally, before we end this video, let's cover next.config.js. So in the images object, we can see a domains property, and then inside that array, we have ipfs-infura.io. And this is done so that we can access remote images and still use the built-in Next.js image optimization API. And also this protects our application from malicious users. So it's best practice to define the remote URLs that we'll be using for images, which is ipfs-infura in this case. So that's basically it for the front-end application. In the next video, I'll put some finishing touches and test and demo the final version of the application. So see you in that next video, and thank you for watching.